Okay, let's start today's lecture. So the topic for today's session is some new data types called tuples and lists, and how they behave in memory and when being assigned to variables. So we will talk about aliasing and cloning. And lastly, we will see what's the difference between being mutable and immutable between these types. So last time we discussed functions, and we saw that it's a way to create some structure within our program, and the concept of abstraction, which suppresses the details of how the function was implemented, as opposed to how someone can simply use it by providing a certain set of arguments or parameters, and getting back some results. So we will be using functions a lot going forward, and it would be useful if you review that, do some exercises that we shared, and understand the working of functions in detail. So today we will introduce some new data types, which are compound data types, which means they have more than one elements in them, and those elements essentially are the scalar types int, float, bool, and string. So one of them is called a tuple, and the other one is called a list. And we will see what the difference is between both of them, how they behave, what operations we can do on them. And lastly, we will be talking about when we assign one variable to another or its value to another, how does aliasing and the concept of cloning comes in. And as I said, we will talk about mutability. So let's see. So tuple is the first data type that we will be looking at. It's an ordered sequence of different elements, and we can have more than one type of elements as part of this compound data structure. But it is immutable, which means once we define it, we cannot change the individual elements within a tuple. And that was exactly the same case with strings, that once we define a string, we cannot change the characters from within a string, but we can slice it, assign the subset of the string to another variable. Those kind of operations we can do, but we cannot mutate it. So the way to define a tuple is that we use these parentheses, and this statement t is equal to empty parentheses. This defines a new tuple variable, which is represented by t. Okay, and then in the next statement, we are assigning it a value. And the value that we are assigning is the number 2, a string MIT, and a number 3. And you will notice that 2 of them are integers, but 1 of them is a string, which is perfectly all right for a tuple to contain. And same kind of operations as we did on string elements. For example, if we say, give me the element at index 0 for this tuple, the result will be this the first item at index 0. We can also concatenate 2 tuples together. For example, if we say that add this tuple containing 3 elements plus another tuple containing 2 elements, the result will be a tuple which contains all of those 5 elements. And exactly as we did for strings, we can slice them. Here I'm saying that start at index 1 and go to 2 minus 1, and this would result in only in the second element, which was at index 1. A single tuple, you see here the notation is a little bit different than just parentheses. And this extra comma here identifies that this whole thing within the parentheses is a tuple data type. Another operation, we say that start at 1, but get me up to index number 3 minus 1. So that would be the second and third element, MIT and 3. From here, we can also ask for the length or number of elements within T. So len is a function, built-in function of Python, which gives us the length of T, which is 3, because we have 3 elements here. And lastly, if we try to change a certain index of this tuple, for example, we say T at 1 should be equal to 4, which is this string here. This statement would give us an error. That's because tuples are immutable. Once we define them, we cannot change their value. Okay, let's move on. So what do we do if we only define them once? We cannot even change their value. They're very useful in certain instances. For example, if we have to swap 2 variables, we cannot say simply, so there is a variable x and a variable y. And we say we want to put the value of x in y and the value of y in x. If we simply give these two statements, that x is equal to y and y is equal to x, this doesn't work. Because as soon as you set the value of x is equal to y, x's original value is gone. And when you say y is equal to x, they would exactly be same numbers. So the workaround for that is that we say, okay, put x in a temporary variable and then give x the value of y. And and after that, the temporary value of x that you put in temp, assign that back to y. So that this would successfully swap the values of variables x and y. But you can do exactly same thing with this simple statement using tuples. You say x comma y is equal to y comma x. This is a tuple. This is also a tuple, and this operation swaps these two values very, very efficiently. At the same time, if you remember from our previous lecture when we talked about functions and return values, we said that the function can only return once. But what it returns is can be a single value, but it could also be a collection of values or a compound value. So here, this small function is the function body here. What it's trying to do is it's getting 2 integers, 2 numbers, x and y, and it will return us the quotient and the remainder of that division between these 2 numbers. Okay, so we do 2 operations. We say q, a new variable, q is equal to x integer division y. What this double slash instead of a single forward slash does is that it gives you the integer value of this division. And the other part of division is that after the integer division is done, there is some remainder, okay? And that value we are putting in this variable r, and then we are simply returning a tuple, which is a set of 2 values. One of them is the quotient and the other one is a remainder. So when we run this statement here, and we say a tuple quotient comma remainder is equal to this function call, and we are giving it the value of 4 and 5. What it will do is it will divide 4 with 5, and the answer is 0 point something, out of which the integer portion of that division is 0, and the remainder is 4 itself. So the return values from here would be these 2 numbers resulting from these two statements. So let's take a look at it in our code file. So same function, quotient and remainder, getting 2 variables x and y as arguments. The first operation is the integer division. The second operation is the finding out of remainder, and then we are simply returning q comma r as a tuple back to the calling function or the calling global scope. So we call it, we get these 2 values back into these 2 variables, and then we are simply printing it. Let's run it and see what we get. So when we give it the values of 5 and 3, 5 divided by 3 is 1 point some value, some decimal numbers after that. So the integer portion of that division or the quotient is 1. And what's the remainder when we divide 5 by 3? So one multiple of 3 would come out of 5, which is 3 itself, and the remainder of that full division is 2, and that is the second number here in the remainder. So that's simply this concept of returning more than one values as a tuple back to the calling function. And both of them would be assigned. This R would go into remainder, this Q would go into quotient when we run this line number 5. Okay. So how do we manipulate them? We can iterate over them. We of course cannot change their value, but we can slice them. We can iterate over them, and during that iteration, we can do certain operations of breaking them up or finding the min max kind of numbers between them. Okay, so here is a simple function which says get data, and it receives a tuple as a parameter. Okay, so this tuple is a data type, and this object, the outer parentheses define that this whole thing is a tuple, and within that I have 3 more tuples. Okay, so that's how I will call this function. Okay, and within each of these tuples which are part of it, the first one would be an integer, the way I will give it the data, and the second one would be a string. Okay, so for each one of them, first one is an integer, the second one is a string. What I'm trying to do here is to take out all the integers, which are the first elements of each of the tuples within this parameter tuple, and I am going to put them in an array in another tuple called nums. And the second parameter, which are strings, I will put all of them in words, but with a twist. So I say for t in a tuple, which would iterate over this argument variable. And it would say simply that nums, which was a tuple that we defined earlier, should be extended by whatever is the first element within this tuple. So for each of these iterations of this for loop, it would get one of this value. First one would be this. In the second iteration, it would get this. And the third iteration, this would be pointing to the variable t here. Okay. And within that, we know the first element is an integer. The second is a string. So we say the first element should be, the value of the first element should be added to this variable that we defined, should be added to the tuple that we defined earlier, nums. Okay. And then for words, for the second argument, what we do is words initially is our empty tuple. And we do a simple if statement here that if that word is not already present in our tuple, resulting tuple words, then add it. And then we are doing a bunch of operations here. Okay. So let's see how this code works. Okay. Right. So the data that we provided in this function call, the top part here is the function itself, and the end it would return a tuple of 3 values, the minimum of all the integer values, which were all the combination of the first values within this tuple, the max out of them, and then how many unique words were there as part of all of the second elements of this argument here. Okay, and let's say we call it with we are creating a tuple which says 1 comma a, second element is 2 comma b, third element is again 1 comma a, and fourth element is 7 comma b. All right, And we are getting back three variables A, B, and C, which are the minimum value, the maximum value, and the unique words. All right. And then we print them. Okay. So minimum of all of these numbers, 1, 1, 2, and 7 is 1. So this is this first printed output of A. The second output that we have is the max of all of those integers, which is this B comma B, which is 7. So out of 1, 1, 2, and 7, 7 is the maximum number. So that's what we printed here. And out of A, B, how many unique words are there? A is being repeated twice, B is also repeating twice. So C would have the unique words out of all of these strings. And the number of those unique words is 2. And the way we did that was with this if condition, that if it's not already in there, then add it. Otherwise, just don't add it. It would skip this statement, line number 34. So that was a simple use. If we try to do a little bit more meaningful example, let's say we want to know that between these years, or this is a list and it can contain any data, but we gave it the data of Taylor Swift's songs, in which year she wrote a song about which person. Okay. And we will do exactly the same operation on this list. And we are getting same three numbers back: minimum of the year values, maximum of the year values, and then number of people that she wrote songs about. Okay. And then we will write a little bit meaningful statement here that from minimum year to maximum year, she wrote songs about how many people. So when we run this, we get a statement back that from 2008 to 2014, Taylor Swift wrote songs about 5 people. Okay, so the minimum of these years is 2008. The maximum of these number values, which are years, is 2014. And the unique names in this second part of each of those tuples is 5. So that's how we know that from 2008 to 2014, she wrote songs about 5 people. So that was a little bit more meaningful use of this same function. Okay, let's move on. Second data type that we will look at today is list. Again, it's an ordered sequence of same kind of information that we can put in tuple. It is also accessible by indexes like 0, 1, 2, 3. And unlike tuples, which were represented by parentheses here, when we create a list, it is identified by square brackets. So when we say a variable name is equal to square brackets, that means that variable is a list. Okay, and it what does it contain? It can contain anything, but based on the kind of operations that we want to do on that list, usually it contains either all numbers or all strings. But we can also put anything in it, and we will see a few examples for that. So since list is mutable, unlike tuple, which was immutable, we can change specific elements within a list. Okay, so we say, okay, from now on, let's change this to this. Okay, let's take a look at some examples. We say a list is a variable which is empty in the beginning, and then L is another list variable which contains a few elements. First one is a number, second is a string with just one character, third is another number, and fourth is another list by itself. So this kind of combination and mixing of different data types as a value of a string of a list is allowed. It can be done. So length of L. How many elements do we have here? We see a lot, but there's actually only 4. 1, 2, 3, and this whole list is the 4th element. What's at the 0 index? It's number 2. And if we get item at index number 2 and add 1 to it, which was 4 plus 1, it results to 5. At list number 3, at index number 3, which is 0, 1, 2, 3, is another list, which is 1, 2. But same as strings, if you try to access an index which is not present, 0, 1, 2, 3, there is no 4 here. So if we try to access L sub 4, that would give us an error. Okay, and the indexes can be any kind of formula. So if we say I is equal to 2 and then get me something at I plus 1, I minus 1, which is 2 minus 1, which becomes L sub 1, which is 0, 1. So this would return us the value of A. It's very simple operations. Changing elements, they are mutable, okay, which means we can change certain elements at any index that we want. So if L is 2, 1, 3, which is 2, 1, and 3, and we say at index number 1, which is this one here, give it the value of 5. And once the second line is executed in our code, L itself now becomes 2, 5, 3 instead of 2, 1, 3. This L is still the same object. We did not create a copy. We did not slice or concatenate. We just changed the index number 1 from 1 to 5. So that's the aspect of mutability of lists. How do we iterate over the list? I think we saw this example for strings in a previous lecture. You can iterate in 2 different ways. You can give a range of indexes using the length of this list and then get a specific element at the index. But you can also rewrite this as simply as for I in L and then use this value of I. So for every iteration of this for loop, each index, the value at each index would be put in I, and that's what we can use in the inside in the statements inside for loop. And these two pieces of code do exactly the same thing. And similar to strings, the indexes on a list start with 0 and go all the way to length of L minus 1. And when we use range function in for loops, that also goes from 0 to n minus 1. So it's usually very intuitive to use length L, but if we use it this way on the right, it's more intuitive. Let's take a look at this example. These two functions, sum of elements method 1, sum of elements method 2. The first one is using the index and range functions to get the values from within L. The second one is simply saying that for each I in L, just add that value back into total. So if we call it with 2 exactly same lists, the result from both of these functions would exactly be same, and which is 10. 1 plus 2 plus 3 plus 4 is 10, and for the second method, it's also 10. What other operations can we do on lists? We can add elements to it, and there are many different ways of doing that. One of them is using the append function. We can say that append means add something at the end. Okay, so if L was 2, 1, 3, and we say that L dot append 5, the list now becomes 2, 1, 4, 5. Okay, it should be 2, 1, 3, 5. That's a typo here. So let's talk about this dot here. You remember we said in the beginning that in Python everything is an object. So what is an object? Object is a data structure which has some data, and it also has some behavior. And behavior is defined by the functions and methods which are part of that data type. And this append is a function which is part of the list data type. And the way we can use any of those functions which are part of its behavior is by using this dot in front of the variable name and then calling that function, which means the append does something which is meaningful only in the context of this data type of whatever variable it is calling. Okay. So different types of data types have different types of functions defined for them that do operations on them. Append is a function that works on lists. Okay. And this is the simple notation that object name dot do something. This is the type of object, an instance of a specific type of object, and this is a function which is defined as part of the definition of this object. And we will learn more about this when we talk about classes in a future lecture. So adding to list has some other options. We can concatenate using the plus operator as we did for strings. And we can also use a function called extend. So let's say if L1 was 213, L2 is 456, and we define a new variable L3, which is the concatenation of L1 and L2. Now L3, once this is executed, L3 would be 213456, all of these together, because we use this concatenation operator plus here. We can also say extend. If we say L1 dot extend and we give it another list of 0 and 6. So in L1 we had 213 and the result would be 21306. And notice here that the list L1 itself has been updated. We did not create a new list. We just said that add these two new elements at the end of the existing values of L1. So L1 itself now mutated to this new list having 5 elements. Similarly, we can do remove operation on lists, and there are a few different options here. We can use the delete function, and then we can also use the pop function of list. Delete is not a function of the list object, so it is called, and we give the list and specific index as an argument to this. Whereas pop would remove the last element from the list. So let's take a look at some examples. Also, we can use the remove function, and let's take a look at these examples of how each of these work. So we say L, our list was 2136370. Okay. And if we do these actions, run these, execute these statements in this order, first we say L dot remove 2. Okay. And what that would do is that this element, so remove functions searches for this element and removes the first occurrence of it from the list. Okay. So when we say L dot remove 2, that would mutate L to this first element would be removed. So remaining items would be 136370. Okay. And then we say, okay, now remove 3 as well. As I said earlier, remove would find the first occurrence of this element and remove it from the list. If there are more 3s after this, it wouldn't worry about that. It only removes the first one. So this first 3 would be removed, and the result L would now become 16370. Okay. Then we say, okay, delete from L the item at index number 1, which is the second item 1 here. Okay. Sorry, this was the original one. Our current list is 16370. When we remove the item at index number 1, which is the 6, the remaining elements are 1370. And this last example is popping an element from this L, which simply means that removing the last element in the list. And it would also return back that the value of that element. So 1370, if we run this pop function on this, the 0 would be gone and the result would be 1, 3, and 7. Okay, these are some simple examples of removing elements from strings. And lastly, it's sometimes very useful that we convert a list to a string if it contains all characters. But we can also convert lists back to strings. And here's a simple example. The two functions that we use for this purpose are called split and join. So split would convert a list into a string into list, and join would join the elements of a list back into a string. And there are two examples here, but there are many different uses of it. We will take a look at this example in code as well. So if we say S is a combination of these characters, I less than 3 space CS, okay, and we say that give me list of S, which means give me S as a list. What it does is every element in this string would become an element inside a list. Okay. So there were 1, 2, 3, 4, 5, 6 characters in this string. We would get a list with 6 elements. 1, 2, 3, 4, 5. There's a typo here. 3 is missing. Don't worry about it. If we then say split the string, but split it using this delimiter, I can give any kind of character which is present here. I can split on this space. I can also split on this less than sign. So if I split S at less than, I would get two values in my list. One would be whatever was before it, and one is whatever is after it. If there were more than one occurrences of this sign, which I used here as a delimiter, that would become, anything after that would become an extra element, third element, or fourth, or so on after this. Another example, if L is ABC, and then we say join L, here I'm calling this function join with the dot in front of an empty string, which means it is a function of the data type string. So I'm asking to join L, simply join it. So ABC would become the string ABC. But if I call this with this delimiter underscore and call the same function join, it would join all the elements, but it would put an underscore between them. So that's another use of this. Sometimes it's useful. There are two other operations, important operations that we do. One is sorting them, and the other is reversing them. And for sorting, we have two options. One of them is a function of the list data type, and the other one is a general function not defined within the data type. And the reason and the way they behave is a little bit different. They do exactly the same thing, but not exactly. Okay, so if L is 9603 and I say sorted L, okay, it returns me a new list, which is the sorted version of the same list. Okay, but the L itself, the original value of L does not change. But if I say L dot sort, it probably does not return anything, but it sorts the values within L and changes the value of L. And similarly, reverse would change the values, change their order so that they become reversed. Okay. So this statement would simply return us a new list, which is the sorted order of these 4 values. But if we call L.sort, the L becomes 0369 instead of 9603. And then if we call reverse after this, the values within L will become 9630, 9630. Okay. Let's take these, take a look at these in our code. So I have a list L1, L2. We saw this in our slides, and then I'm simply concatenating them. And then in list 1, I'm adding 0 and 6. Here I have some remove options, an example of all 3 of them. And then I'm splitting the example that we had. And lastly, I'm using the sort and reverse operations here. Okay, so so this is the result, the splitting of our string into array, and then splitting using a delimiter of less than, and then this was the value of the string that we defined, and then we this ABC, we joined it without any delimiter here, and we joined it with the delimiter of underscore. And we are printing the sorted version of L and then sorting and reversing it. If I print L once again here, I think as we saw in the slide, let's see, print L. Okay. Our last printout would be the reversed version of the previous, whatever the value was of L before this statement. Okay, let's go back to slides. Okay, we talked about mutation, but we haven't yet talked about aliasing and cloning. And this is a very, very important topic to understand as we work with the tuples and lists, what is meant by aliasing and what is meant by cloning. Okay, so lists are mutable objects. They are present in the memory when we define them, and they behave a little bit differently than immutable types because their values can be changed. Okay, and variable name that we have in our code points to the value that resides in memory. And the concept of aliasing is that you can have more than one variable name pointing to the same value in memory. And that would depend on how you defined them. We will take a look at a few examples for that. But the important thing is that if we are not careful, there are many side effects when we use these different variable names for the same value in memory. We change one of them, and if you're not expecting a change in the other, we would be surprised. Okay, and that's where the concept of assigning the value in memory of one variable to another one, as opposed to creating a copy of it in memory, which creates a copy of all of those values as a new physical memory, and then assigning that to another variable. So there is a difference between both of these concepts. One of them is aliasing, and the second one is cloning. Okay. So we say there are some attributes of a person, and that person is singer and rich. And there are many names that we can use to identify that person. Okay. If all of those names which are used to identify the person are pointing to the same set of values in memory, and we change one of them, okay, all of the other ones will also be changed because they are aliases of each other, as opposed to clones of each other. Okay. So here is an example. This is from that website that I shared earlier from Python Tutor. This is what happens in the memory. If we do certain operations, I will explain them. So I say A is equal to 1, okay, B is equal to 1, and then I print A. Sorry, B is equal to A, then I print A and print B, okay. A is equal to 1 and B is equal to A. we are not giving a physical value to B, we are pointing B to the same variable in memory for A, okay? And it would, when we print A and B, they would both be 1. Secondly, if we, so our scalar variables and non-scalar or compound data types, they behave a little bit differently. For a list, I say warm is a set of colors, a list of colors, red, yellow, and orange. And then I say hot is equal to warm, okay? So I defined warm and gave it a list. And then I said hot is pointing to the same items in the memory. If I change one of them, if I change only hot set of values and append pink to it, and I print both of them, it would be exactly the same printout because they are both pointing to the same object in memory. Okay. I believe we have an example for this. And this is an example of aliasing. B is equal to A, A is equal to 1, B is equal to A, then print A and print B, and they would both have same value. And then warm colors are red, yellow, and orange. Hot colors are same colors, which are defined as warm, but I'm also adding pink to hot. And if I try to print hot and warm both, I would get exactly same result because hot and warm are aliases. After this statement 112, they are aliases for the same variable which is physically present in the memory. Okay, so if we are not careful in our operations, when we assign one to the other, that would be there would be unexpected results in our program. So what happens if you really do want them to be, you want to use one as a source for creating the other one, but you want them to be physically different. This is where we create a copy. And if you remember our slicing operations on strings, we use this notation of single colon within the square brackets, which creates a copy for all the elements of cool. It would create a copy and put all of those new elements, which have exactly the same value, but they are new, into chill. Okay, so we say, and this is called cloning. All right, we say cool is these 3 colors, blue, green, and gray. And chill is now a copy, a clone of everything that we had in cool. And we add black to chill, okay? And when we print both of them separately, and we would get 2 different set of values. And this operation of making a copy or cloning here is the key to this different behavior as opposed to the previous example that we saw, okay? Let's see this example of cloning in our code. Okay, cool, chill. Chill is a copy of cool. And then I'm changing, adding a new element to chill and printing both of them. Okay. And the printout here, as you see, as opposed to the previous one that we saw in the previous example, here, the value of both of these is different. And the key is here in this line number 121 as opposed to line number 112. We are using a simple assignment here that would create an alias of the same variable with a different name. Over here, we are creating a copy and then assigning the value of that copy to this new variable. That would be the key difference between aliasing and cloning. Okay, let's move on. How do we do the sorting operations on the list? As I said earlier, one option gives us the sorted list back, and the other option sorts the list wherever it is located in memory and changes the original value. Okay. And the way we call them is a little bit different. One is called with the dot operator because it works on the same object, and the other one is simply a call, and we give it the list as an argument, and it returns basically returns the sorted value back as a copy. So we have warm colors, red, yellow, and orange. And we say sorted warm is equal to warm.sort. Now this warm.sort mutates the original list, okay, and it does not return anything. If I try to print sorted warm, you would see its value here in the variable watch is none, which is, it returned nothing. It returned a none type. In the second example, I say cool colors are gray, green, and blue. And then sorted cool is another variable which for which I said, okay, give me the sorted version of cool. It would create a new copy and give it back to sorted cool. And if I print both of them, one is original without sorting, and the second one is sorted by their alphabetical values. Okay. I believe we have this example here. So same operations as we saw in the slide. Our original list of warm colors. None is the output here for warm, where we sorted warm, but we sorted the original variable. We are trying to put the result of this call into this variable called sorted warm, but this function sort does not return anything. It sorts this variable itself, the values within this list itself. Okay. And then we have the unsorted original version and the sorted, alphabetically sorted second version that we got with this sorted version, sorted call. Okay. What else can you do with lists? They're pretty versatile in their behavior. You can have nested lists. For example, here I have a list which has two lists in it. One has two elements of yellow and orange, and the second one has only one element of red. Okay. This is a list with two elements. Here is a list again with two lists, one with two elements in it, and the second one with another two elements in it. And the changing of one of them, if we are aliasing them, would be quite unexpected, and those side effects you have to be very careful about. There's a lot going on in here. This is a view from Python tutor. If we run these statements, there are some variables in the global frame. They point to more than one values, and as a result, our operations would have a little bit of unexpected results. Let's simply look at this example in the code instead of explaining it over here. So we have a warm list. We have a list of hot colors, and then we say bright colors is a list which contains the list of warm. So it's a list within a list. And then in bright colors, we are appending all the elements of the hot list. Okay. And then we are simply printing it. And this would be the behavior. I think you should try to run it and see what happens in Python tutor. It would be more clear. So there are a lot of side effects if we use aliases instead of cloning. Okay. One last concept for this class is many times we iterate over lists, and then we also do operations on them. Those operations can be of different type. For example, earlier in the lecture, we saw that we iterated over a list and we added all of the element values into a new variable for the total. In our second example, earlier in the lecture, we iterated over a list of strings, and then we checked our resulting final list. If there was no duplicate already present in there, we added those values. Okay. But what happens if you change the original list as you are iterating over it? Okay. Here, this example remove duplicates, and this function gets two lists as an argument, and we say iterate over L1 and then iterate over L2. Iterate over L1, get the value in the variable E. If E is present in L2, remove it from L1. Okay. So if L1 was 1, 2, 3, 4, L2 is 1, 2, 5, 6. If any element from this list 1 is in list 2, it should be removed. So 1 should be removed, 2 should be removed, answer should be 3, 4. But it's not 3, 4. It's something different if we run this code. Okay. This is our first implementation of removing duplicates, and this is our second implementation of removing the duplicates. And if we use our first option, need to print as well. 2, 3, 4. Okay, but that doesn't make sense because we wanted to remove everything which is a duplicate, okay, which is 1 and 2. But why is 2 still being printed? The reason for that is, you remember for our for loop, this E would iterate over L1, and this index would automatically be updated every time we go back for the second iteration and third iteration and so on, okay? But if we change our original L1 as part of our operations within the loop, that doesn't change where the index was located. That would still go on to the next one. So what happens here is that we simply skip over this second item. Because our index is at 0, we found 1 to be a duplicate. We said, okay, remove it. So when 1 is gone, 2 comes at the index 0. But our internal index for the for loop is next time checking on item number, item at the second location. Once we run this operation here, 1 is gone, 2 comes back here, and the second element becomes 3, which is not a duplicate, so it won't be removed. 4 won't be removed. But we never looked at item number 2 because of this operation that we did within the for loop. And the way to overcome this issue is that we always create a copy in the beginning. We change the original list, but we run our operations, we run our iterations on the copy, so that the copy or the list of original elements never change. We are still trying to find the duplicates, but the change we are making is not on the variable that we are using in our for loop iterations. So that way we can overcome this issue by using a clone of that list instead of the list itself. And this becomes applicable only if you are modifying the variable that you are using within the iteration of your loop. Okay. So second time around, 3, 4 is the right answer. 2, 3, 4 is not the right answer for us. Okay. I believe that's it for the examples and for the lecture as well. We will end this lecture here. Thank you. Okay, bye.